All right, class, welcome to chapter 4.2. We're going to be talking about exponents and polynomials. If you have a math book, you're going to notice there's going to be a lot of definitions, a lot of talk about polynomials, binomials, trinomials, terms, coefficients, all these words. I've decided that in the work I show you, I'm just going to throw these terms at you in the problems, and as we go along, I'll continue to say these words, and hopefully you'll just kind of catch on to what they are along the way, as opposed to just going through each one and telling you to memorize them. So let's start. All right, what I'm showing you here, this is a polynomial, but to be more specific, it could be called a binomial because there are two terms, okay? A term, again, I will use that term often and you'll catch on to exactly what a term is. Now this can be written, had a typo, careful, can be written the same as this. These are equal. Okay, so notice that here, this polynomial, it has x in it, and we can also consider that there's an x here to the 0 power, and this turns into a 1. And so the idea is that a polynomial has descending, or it's written in with terms that have descending powers in the variable that we're using. In this, we're using x. X is the variable. Okay, term here is x, the term here is 2. Okay, here I've written a trinomial. It is a polynomial also. I will rarely be saying binomial, trinomial. I will pretty much always say polynomial. Notice this has an x squared. I wrote the squared in the leading spot because it has the highest power. The next spot I have just the x because it has the next descending power. And then again here we have the x to the 0. So this is how this would be written. Now let's say we had something like this where we have, this is x to the first power, x to the 0 power, and then an x to the negative 1 power. This would not be a polynomial because it has a negative power. So a polynomial is only going to have variables that have positive powers, and those powers are going to be integers, in other words 1, 2, 3, 4, and so on. All right, notice what I have here. Again, this is a polynomial. It has 1, 2, 3, 4, 5 terms. The variable we're using is m. Notice the leading m is to the 3rd power. Gotta be careful on my typos. It's to the 4th power. 9m to the 4th power plus 5m to the 3rd power minus 4m to the 2nd power plus m minus 1, which, remember, there's an m to the 0 power here. It qualifies as a polynomial because none of the powers are negative. They're all whole numbers. The 9 is the coefficient here, the 5 is the coefficient here, the 4 is the coefficient, a 1 is a coefficient here, same with this one. Degrees, that rarely comes up, but I will explain it. The degree of this polynomial is 4. Whatever the highest power of the variable is going to be the degree. So the degree here is 4. If I had just this problem, the degree would be 3. If I had just this problem, the degree would be 2. And so on. This degree would be 1. This degree, this degree would be 1. All right, so let's start looking at combining like terms. Okay, these are two terms. They are like terms because they both have the same variable to the same degree, x squared, x squared. So here I have 14x squareds. Here I have 9x squareds. So I can add my coefficients. So I get 23x squared. Let me fix my x. Here's my next polynomial. Okay, this one has a y, and it's okay to have different variables as long as those variables have powers that are not negative and they're whole numbers. It's okay. So here I have 15x squared minus 3x squared. I can combine those. So I get 12x squared minus y. And at this point, these terms are not like terms, and I cannot add them. So this is my final answer. Here is my next problem. 0.1y squared minus 1.2y squared plus 6.7 minus 1.9. I can combine these two. These are like terms, just as these are like terms. So I can add 0.1 to negative 1.2, and I get a negative 0.2y squared plus 4.8. And I have correction. I looked at this number incorrectly. Turns out it's negative 1.1. My mistake. I thought my 1 was over here, and no worries. You guys can get through this. You are learning, and you're going to continue to learn. Let's go. Here's my next polynomial. Looks like I have an x squared. I have an x cubed, or x to the third. I'm going to start saying x squared instead of x to the second and x cubed. That will come up a lot later. I have an x squared here, x cubed here. So first I'm going to take care of my x cubes because I need to write those first because that is that's going to be my leading term. Now notice kind of crudely, before I add those, I am going to put a 4 times 4 here. This is like my phantom 1, and a 3 times 3 here. This will make my denominators the same. On the top I'll have a negative 4 and a negative 3. That's going to give me a negative 7. So I'm going to get a negative 7 over 12 x cubed. And when I start to have bigger problems, I like to cross out the things I've rewritten, so I've done that here. Looking at my x squared terms, this is 1x squared, which I'm thinking of as a 5 over 5 because of this. So if I have a 5 over 5 and a 2 over 5, I'm going to end up with a 7 over 5x squared. Here's my term. Cross those out. And I get a 6. So this ends up being my final answer after I've combined my like terms. Alrighty, we've got a lot going on here. X squared times y plus x times y minus y plus 10 times x squared times y minus 2y plus yx. So we have 1, 2, 3, 4, 5, 6 terms. I think the first terms I notice are probably these two that I'm going to add. I have 10x squared times y. This is a x squared times y. These are the same terms. I can add them. There it is. Cross those out. Now next, this is kind of a tricky, subtle thing. This is yx and this is xy. According to the rule of the associative property, these numbers can be either switched and it doesn't matter. So multiplication can go to left to right, right to left. So these terms are the same. So I can add them. There it is. Cross those out. And my last two terms each have y's in them. I have a negative 1y and then a negative 2y. So a negative 1y, a negative 2y is going to give me a negative 3y. There it is. For our next term, this is quite... there's just one very subtle thing we have to be careful of, and really it's the negative sign. Because there are parentheses here, the negative is going to have to apply to here, and it's going to change the signs on the inside. But over on this side, I can take my parentheses down because this is just adding. There's nothing being multiplied outside the parentheses, so those can go away. And so now this becomes a plus 2y squared and a minus 4. So here I have a plus 4 and a minus 4, and those just cancel, and then a 5x squared plus 5. These cannot be combined, so here's my final answer. And here again we're going to have to just pay attention to our sign. We have an x and an x. The sign is what matters. I'm just going to write positive, so I'm going to have a negative 15x plus a 4x. I end up taking their difference and I get a negative x. Alright, and I'm going to finish this off with kind of a long problem. And again here, it's really just about paying attention to the signs here. These signs are going to apply to everything inside. Really this negative is kind of the only one, so here we go. So I can actually start by dropping my parentheses here, but here I'm going to have to apply the negative sign to each of these three terms. And so this is what I end up with. I have a negative x squared minus an x plus the 1. The negative sign turned to a plus. And then here in this last one I have a plus a negative x, so this negative sign is going to come out. And actually, I just erased the parentheses and the sign, and it just ends up being minus x. My leading terms are the x squared, so I'm going to start with those. 3x squared minus 2x squared. That gives us an x squared. Cross them out. All right, with a 5x here, a 5x here, a minus x and a minus x, so that should be like 5 plus 5 minus 1 minus 1. I get 8x. Cross them out. And with a minus 8 minus 2 plus 1, I get a minus 9. And here is my final answer. All right, there's our first lessons working with polynomials. Again, I'll be saying the word terms. Here we have 3 terms. The variable is x. This is the degree of 2. This is a degree of 1. This is a degree of 0. The coefficient here is 8. The coefficient here is 9. Get used to these terms. These words. We'll be using these words a lot. See you next time in class, kids. Students. See you next time.